Now finally moving on to question 8, we have a very long question, and it's not particularly exciting, it's just to do with crayfish, but this is a coupled differential equation question, okay? So we have these two differential equations presented in the question, and we have numerous parts. We're going to be doing different things like finding general solutions, showing certain things hold, and suggesting limitations of the model. So let's start right at the beginning and just slowly work through this. So we have to show that this equation here holds for 3 marks, and we're given two differential equations, and we're just asked to show that this is here, what this is here. Now, there's not really much to go off, but you kind of got to look at what it's in terms of, okay? So this is in respect to dw by dt. So we have dw by dt here. So what we've got to do is we've got to use this differential equation, but rearrange it to be in terms of s, because we need the derivative of s with respect to t, okay? So to do that, I need to rearrange to get s and then differentiate. So let's rearrange that. Well, if I expand this first, so dw by dt, that will be equal to 5 over 2w, 5 over 2w, minus 5 over 2s. Like so. Okay, so rearranging this now to be s equals, well, that's going to be 5 over 2s, so taking this across to the other side, is equal to 5 over 2w minus my differential area of w with respect to t, minus dw dt, like so. And then finally I can just simplify this by dividing through by 5 over 2, so therefore s is equal to, so that'll just be, well, dividing through by 5 over 2, so that'll just give me s, and then I want to get w here, and then I want to get 2/5 of my differential of w here, so minus 2 over 5 dw dt. Okay, so we've got it in terms of s now, we can keep going, dw dt. Okay, my next step now is just simply to differentiate this s here. So if I differentiate this, so ds, and with respect to t, so my w will just be w, will just be dw dt, okay? So it's w, we're differentiating this w here, so dw dt, and this dw dt, if you differentiate it again, it'll be the second derivative, so it's minus 2/5 of the second derivative here, minus 2/5 of the second derivative. Like so. Now we just need to keep rearranging, okay? But before we do that, what we know is that ds by dt is 2/5 of w minus 90e to the minus t. So now I can sub that in. So what I've got now is, I'm going to write on this side first though, so I'm going to change this onto my left hand side, so I've got dw by dt. My d's look pretty bad today, so dw over dt minus 2/5 d squared w well, this is going to be equal now to what I said here when we sub it in, 2/5 of w, 2/5 of w minus 90e to the minus t. And now finally, all I've got to do is keep rearranging it. But before I do that, notice this is 2 lots of the second derivative here, and this is 2/5. So to get it as 2 lots, I need to times through by 5. So if we do that, we're going to get 5 lots of dw by dt minus 2 lots of this This is going to be equal now to 2w, times that by 5, you just get 2w. And this will be 90 times 5, so this will be minus 450e to the minus t. And then finally, if we rearrange it all to give us the final step here, we're going to obtain this. So therefore, if we do it down here, we're just going to get what we need. So it's going to be 2 lots of the second derivative minus 5 lots of dw dt plus 2w is equal to 450e to the minus t. And we've got part A done there now. Now for part B, we're asked to work out a general solution here for the number of white-clawed crayfish at time t years. So 6 marks for this, so it's going to be quite a bit of working. Now starting off straight away, we need to write down an auxiliary equation here. So we've got 2 lots of the second derivative minus 5 lots of the first derivative plus 2w. So remember, we replace our derivatives with m. So the second derivative would be m squared. This first derivative here would be m, and then this will just be a constant. So it's just 2 lots of w, so that's just going to be plus 2. So if we write this down, this will be 2m squared minus 5m plus 2. And we set this equal to 0. And now we try and solve this. So hopefully this will factorise, and you know, a lot of the time it will do. So if we factorise this, nice and easy, this is going to be 2m minus 1 and then m minus 2. M minus 2. Okay, and this is still equal to 0. So now we can solve this and get our values for m. So therefore, m will be equal to 2 and a half. Okay, so 2 and a half. So now we need to get our complementary function and our particular integral. So straight away we can write w. So remember, you judge your complementary function based off what your values are for your auxiliary equation, what they come out as. So for this one, it's just going to be AE. And remember, this A is just a variable here. It could be whatever letter you want in the alphabet. It is good practice just to use A and B. So this is going to be A e to the power of alpha t, like so, plus BE to the power of beta t, like so. Okay, but we know alpha, so this is the half, and my beta will be 2 here. So this is going to be equal now to AE. So this is going to be to the power of a half t, or 0.5t, 0.5t, plus BE to the 2t, like so. Okay, so that's a half there, 0.5t. Now we need the particular integral. So for my particular integral, what we're going to do is we're going to let w be equal to lambda e to the minus t. So let w be equal to lambda e to the minus t. Okay, so this again, this lambda here can be k, y, whatever letter you want, but again I'm just going to use lambda here. Now I'm going to differentiate this 2 times, so we've got our second derivative and our first derivative here. So if I do it over here, w prime, that will be minus lambda e to the minus t. So nice easy differentiation, minus lambda e to the minus t. And then finally, the second derivative, so w prime prime, this will be just lambda e to the minus t. The minuses will cancel here, so it would be lambda e to the minus t. Okay, so we've got our derivatives now. Now we just need to substitute it into here. Okay, so this is going to be 2 lots of lambda e to the minus t. This is my second derivative, so 2 lots of the second derivative, lambda e to the minus t, lambda e to the minus t, minus 5 lots of the first derivative, so this minus lambda here, so minus 5 lots of minus lambda e to the minus t, plus 2 lots of w, which we know is just this, so plus 2 lots of w, plus 2 lots of lambda e to the minus t, and this is going to be equal to 450 e to the minus t, right? So we're going to obtain a value now for lambda. We can solve this. This is to the minus t. Okay, so we need to simplify this left-hand side here and see what we get. Well, I've got 2 lots of lambda e to the minus t here. I've got minus 5 times minus lambda e to the minus t, so that'll be 5 lots of it, and then I've got another 2 lots here. Okay, so that's 2 lots plus 5 lots plus another 2 lots, so in total I'm going to have 9 lots of this lambda e to the minus t. So 9 lots of lambda e to the minus t, and this is going to be equal to 450 e to the minus t. Like so. So finally now we can work out a value for lambda, and this will give us our solution. So therefore, well, if I divide both sides now, in fact we don't even need to divide. If you think about this, it's going to be 9 times something to give us 450, or again, if you just divide it, you're going to get your value for lambda, so therefore lambda must be equal to 50. You divide 450 by 9, you'll get 50. Now, dead quick, I just forgot to actually write down the general solution in total. So for your general solution, remember, so it's in terms of w here, so it's going to be w is equal, now we always write it as the complementary function plus the particular integral. So for this one here, it's going to be ae to the half t, so ae to the 0.5t, plus 2 lots, plus be to the 2t, plus be to the 2t, and then my particular integral was 50 lots of e to the minus t. Okay, so that's my final solution here, my general solution for part B. But we need this for part C anyway, so it's kind of convenient that I actually forgot it. So that's my excuse. Okay, so now for part C, it's asking us to find a general solution for the number of signal coefficient at time t is. And this is only 2 marks when the previous one was 6. So it's kind of a clue that you don't need to do everything again. You can just rearrange and use your previous answer to help you, okay? So S, remember, well, we already wrote S down before. So S was W minus 2/5 of the derivative of W with respect to T. So that's 2/5 minus 2/5 dW dt. Okay? But we have W here. So if we differentiate this, we can then use it in this S equals here. So if I write the derivative first, so dW by dt, dW by dt, well, if I differentiate everything here with respect to t, that's going to be a half of a e to the half t. So a half a e to the to the half t. So there's a lot of halves there. So ae, I don't like that. That e, so ae to the half t divided by 2 plus 2 lots of be to the 2t plus 2 lots to the 2t, and then minus 50e to the minus t. And now that we've got the derivative, we can now use this in our S here. So, plugging all this together now, and we've got W, this is this, so therefore, S is going to be equal to, hopefully I've got enough room here, in fact I want to do it just down here, just to make sure I've got enough room. So, therefore, S will be equal to, so it's W, so that's this, so AE to the half T plus BE to the 2t plus 50e to the minus t minus 2/5 of all this here. So minus 2/5 of all this. So I don't think I would have had quite enough room to do it over here. So it's kind of good I came over here. Over 2 plus 2 lots of BE to 2t minus 50e to the minus t. Okay, and then if we simplify all this, we're going to get this all in terms of in a and b. We've got our e here, so this is going to be s equals. So it's going to be simplifying all this. I'm not going to actually show all the working because it should be pretty straightforward. So you're just going to get s equals 4/5 of a to the minus, to the half t, plus be to the 2t over 5, so plus be to the 2t over 5, plus 70e to the minus t. And finally, moving on to the last part of this question, D and E, we've got to find a value of t here, where t is the time in years, which the model predicts that the population of white-clawed crayfish will have died out. So 6 marks for this, so again, quite a bit of working going into it. Now, to solve something like this, we need to actually obtain a value for a and b that we just had for our w. So, if we do that, well, we know from the question here that w is equal to 65, s is equal to 85, when t is equal to 0. When t is equal to 0, okay? So can we use this information now to get a value for a and b? Well, of course we can. We can use this information from our last 2 equations, right? So using our last 2 equations, we know that s is equal, for example, to 4/5 of a plus b over 5e to 2t plus 70e to the minus t. So if we set t is equal to 0 into that, we can get a value, and then we can get an a and a b, and then we'll get another equation for our w, solve them simultaneously, and we'll obtain an a and a b. So doing w first, and again setting t equal to 0, so this is going to be 65 is going to be equal to a plus b, because again t is just equal to 0 in this, so a plus b plus 50. Okay, so that's my first equation, and then my next equation will just be my s, so that's going to be 85, so 85 is equal to 4 over 5a, so 4/5 of a, plus 1/5 of b, or b over 5, plus 7a. Okay, so these 2 equations we can actually simplify. Okay, so this will be a plus b is equal to 15, this first one here, so a plus b is equal to 15, and then finally this one here will be 4/5 of a plus b over 5 is equal to 15. But I'm going to times everything through by 5, so what I'll actually get is 4a plus b, so 4a plus b is equal to 75. And now we can solve this. Is just a basic simultaneous equation. So if I add here, subtract, sorry, so I'm going to have a minus 4a, so it's going to give me minus 3a. b minus the b will cancel, and then I've got 15 minus 75, that'll be minus 60. So now we just got to simplify and solve here. So a will just clearly be 20. So a is 20. And if a is 20, so 20 plus something is equal to 15, b must clearly be minus 5. So b is equal to minus 5. So we've got our value for a and b now. Can we use this? And we're using the fact that w, so the white-clawed crayfish will have died out, so w must be equal to 0. Can we put all this together to solve or find the value of t here? Okay, so we're looking at when w is equal to 0. So we've got to use w equals here. So remember, w is equal to ae to the half t plus be to the 2t plus 50e to the minus t. So we're going to set this equal to 0, and we're going to use these values here. So where a was, it was ae, it's going to be 20e, and then we'll have minus 5 e to 2t. So if I put all that in together now, that's going to be 20e, that's a very big 0, 20e to the half t, so 0.5t, minus 5e to the 2t, 2t, plus 50e to the minus t. And that's going to be equal to 0. So, how do I solve this now? Well, the first thing I can see here is I can divide through by 5. So, dividing through by 5, that's going to give me 4e to the half t minus e to the 2t plus 10e to the minus t plus 10e to the minus t. Okay, now I'm going to carry on simplifying this. One thing I can do here is try and obtain this as a nice quadratic. So the nicest way to do that would be times through here by, because this is 10 over e to the t, if I times through by e to the t, this will just be a constant on the end. So we can then start factorising and hopefully I'll use the quadratic formula. So if I times through by e to the t here now, that's going to be 4e. So adding 1 to a half, that would be 1.5t. So I'm going to get 4e to 1.5t. This will be minus e to the 3t, minus e to the 3t, plus 10 is going to be equal to 0. But I don't quite want it in this form. This isn't as easy to work with because the power that's going to be at the front, my e to the 3t, we want this positive, right? We don't want this negative. So if I rewrite this, this will be e to the 3t minus 4e to the 1.5t. So 1.5t minus 10, this will be equal to 0. Okay. So now we've got to solve this. Now this isn't going to really factorise right looking at this. So we're going to have to use the quadratic formula. And remember, when you're solving the quadratic formula, or solving for the quadratic formula, so say this was x squared minus 4x minus 10, right? When we're solving for the quadratic formula, we're actually solving for this middle term here. So that would be minus 4x, so it'd be x equals, for example. So, doing that now, what we're going to get is e to the 1.5t, so e to the 1.5t. So that's going to be equal to minus b, so 4 plus or minus the square root of 16. So I'm just doing my quadratic formula here using this quadratic here. 16 minus 4, and this is going to be all over 2. So this will be equal to 4 plus or minus the square root of 56 over 2. Square root of 56 all over 2. So now we can start solving this. So therefore e to the 1.5t, in fact, sorry, let me just get rid of that. We're going to have to antilog right now because this is e to the 1.5t is equal to this. So we start antilogging, I'm going to get 1.5t. This is going to be equal to ln lots of this. Ln lots of 4 plus root 56 all over 2. So therefore t will be equal to 2/3 of ln, and then this expression here. So therefore, if I do it over here, t is going to be equal to 2/3 ln bracket 4 plus root 56 all over 2. Now the answer wants us to 3 decimal places, so putting this in my calculator, I've already done this, so this is going to give us 1.165. And there we have it, 3 decimal places. That's my value for t there. And then finally for part E, suggest a limitation of the model, just 1 mark. There's a couple of things you could say, but I think the big obvious one is that when the white clawed crayfish die out, so when they die out, the model's not going to be valid anymore. So when the WC die out, model bad, basically. Okay, so to put it in very simple terms, when the white clawed crayfish die, the model is just not going to work, so model bad. And there we have it. That's this full Core Pure 1 paper done. So be sure to subscribe, guys. We're going to keep going through the further Maths 2019 exam papers.